All right, so this one we're doing identity fraud. And if you look in your book, this is number 15. So here the table shows the monetary value of loss resulting from identity fraud between 2004 and 2008. And we're supposed to align the data to the numbers of years since 2004. So, what does that mean? Well, that's 0, 1, 2, 3, 4. No problem. And then we're supposed to write a cubic model for the amount of loss due to identity fraud. Okay, so then we're just going to plug that into our calculator. We're going to get a cubic model and we're done. Then we're going to use the model to estimate the amount of loss in 2009. Well, what is 2009? Well, that's at 5. Okay, so we can do that. And then comment on the usefulness of this estimate. And now, does a model output value corresponding to an input of 2.5 make sense in context, and explain? All right, so let's go over and type this in to our calculator. And as always, I've typed it in so you don't have to watch me type it in. And so now we're going to go over here, and now we're doing cubic, so that's number 6. And we'll go down, and I'm going to put that again in vars, go over to y vars, then 1, 1, and then enter and calc. And so this is going to be my model. So it's going to be 1 times x cubed plus, or actually minus 5.143x squared plus 1.571x plus 59.914. And that would be my cubic model. Okay. Now, what does it look like? Well, that's what it looks like. It looks pretty good. It hits actually all those points, so that's good. And so now that would be my model. And so now 15 says, what is at 2009? So what we can do is we can say, okay, well, let's go second calc, and we want value. And 2009 we said was 5. And so that says that's going to be at 64.2. Now, we'll remember 64.2. Now let's go back to our page here, and let's write down what we have. All right, so we had a model. Maybe we could do L of t, and that's going to be t cubed because we had 1 there, and then we had the minus 5.143 t squared, and then we had a plus 1.571 t, and then we had plus the 59.914, and that was $1 billion. And basically that's the loss from identity fraud since 2004. Okay, and so t was basically less than or equal to 4, but greater than or equal to our 0. Okay, so that was what we got for part A. So B says use the model to estimate the loss in 2009. Well, we found $64.2 billion. Okay. Now, question is, comment on the usefulness of this estimate. Okay, so again, remember, we have to use caution here because we only know really for sure that it fits the data here. Maybe in 2009 it took a nosedive and it went a different direction, or it went way high. I don't know. And so with caution, there's no evidence that we can follow this. So I would say it's extrapolation. So not sure of the usefulness. Okay. And again, with all extrapolation, we never really are sure of that usefulness because, it's beyond what our data is good for. Now, it's the best guess that, yeah, it's going to be $64.2 billion is going to be our loss, but, we just don't know for sure. All right. Now, C, does a model output value corresponding to an input of 2.5 make sense? Well, did we ever add a decimal here? No, we did 0, 1, 2, 3, because we're looking at the end of the year, the whole year. We're not looking at half a year here. So I would say, does make sense? Not really, because looking at end of year values. not mid-year value. Okay. Now, maybe it would work, but we're not worried about what 2004 in June is or whatever. We're really worried about is that end of year, boom, 0, 1, 2, 3, 4, and the extrapolated one of 5 there. So that would be my comment on that one. And I think that's all for that one. Okay, so the next one I'm going to do is median weekly earnings. And so this is number 17. And so it says median weekly earnings for 16 to 24-year-old men employed full-time are given below. Now, why is a cubic model a reasonable choice for the data? Write a model for the weekly salary of 16 to 24-year-old men in constant dollars. Use the model to estimate the median weekly earnings in 2010 and what type of estimate was made in part C. All right, so well, we can do part C pretty easy, or D, because 2010 is beyond that, so that's extrapolation. Okay, so you don't even have to do anything. And so what we need to do is, why is it a good choice? Well, let's go to our calculator. And as always, I've typed in our data, so we're good there. Now let's get rid of whatever graph was there. And so it looks like it's going down, then it comes up, then it comes up again, and it keeps going up. And so because it doesn't look like it plateaus, and we have that inflection point, I would say that's the good reason for a cubic model, because we're not plateauing here at some L value, the asymptote L. And so we're going up, and so I would say that would be a primary good reason to use the cubic model. So now the next thing we need to do is do the cubic model. So we go over here, calc, and then we want number 6 again. And so now we're going to do vars, go over to that, do 1, 1, enter. And so now we have our cubic model. So 0.338 x cubed minus 3.015 x squared plus 13.223x plus 374.860. Okay, so we've got that. And then we were supposed to calculate it at 10. So let's look at our graph to see what it looks like. It's hitting pretty much all the points there, so that's good. And now our value when x is 10. So it's 543.860. Okay, so that gives us that one. And so now let's go back and write all of this down. All right, so we said it was a good model because it's in behavior is unbounded, it looks like, basically going up into infinity and down to negative infinity. And so that's how we're going to say that. And has inflection point. Okay. Now B, the model. Okay, well that was, we had the, let's see, E of t maybe is equal to, now we had 0.338 t cubed, if I can write cubed. And then we had minus 3.015 t squared. And then we had plus 13.223 t. And then it was plus the 374.860, and it's in dollars for median weekly salary. All right, for the 16 to 24-year-olds, I'm not going to write all that, and it's going to be T years since 2000, and T is going to be less than or equal to 8, but greater than or equal to that 0. And then C, we determined in 2010, which was E of 10. We said that was 543.860. Now, notice we don't have any pennies or anything here. And so I'm going to say that's approximately $544. And so that would be a key. We have to kind of remember units on tables. That's going to be kind of our units in this value here. And then D, well, we already did D. It's an extrapolation. Okay, so that's how I would do this problem. And again, I guess the key things were, making sure you had your 0, then 2, 3, 4, 5, 6, 8. And we skipped the 7 and we skipped the 1. And then the other thing was to make sure our number here, E of 10, matched how the table was with no pennies. It was just rounded to the nearest dollar. All right, so I'll stop there and then I'll come back with more.